In this video, we discussed the initial research following the Minnesota Department of Transportation's collaboration with the University of Minnesota's St. Anthony Falls Laboratory to determine a universal method for hydrodynamic separator device performance prediction. SAFL began their research by looking at how HDS devices function, how they are typically utilized, then brainstorming what tests would be necessary for a protocol to accurately represent HDS performance. Researchers determined that two primary metrics are required to accurately predict HDS device performance: pollutant removal efficiency during frequent precipitation events, and pollutant retention during large intense storms. Those performance metrics were then compared to current research to determine whether existing test protocols could be utilized. They found that most research efforts had been focused on determining removal efficiencies of HDS devices during low flows, while research on the retention of previously captured pollutants, or scour, during high flow conditions was limited. Researchers also learned that while some test protocols had methods to test for scour, no protocols had a method to incorporate scour test results into a device's overall performance. SAFL also found that existing protocols were utilizing automated sampling or grab sampling to determine device performance. When SAFL began testing devices, researchers also opted to utilize sampling, but soon discovered that results were not consistently reproducible. More detailed analysis showed that pollutant stratification was occurring prior to sample collection. Essentially, heavier pollutants settle to the bottom of the pipe, resulting in skewed results. Basically, the finer the pollutant, the more accurate sampling is, with testing showing small errors for a clay and silt mix, and major errors for coarse silt and fine sands. Maximum errors exceeded 6,000% for medium sands, the coarsest gradation tested. The significant errors associated with sampling led researchers to conclude that sampling is infeasible for HDS device testing, and that a mass balance method is required. Because no existing test protocols included a method for incorporating pollutant washout in device performance, and because of the significant errors associated with sampling, researchers determined that a new test protocol was necessary, which began a journey that led to the creation of the SAFL HDS test protocol. This concludes this video. Continue to video 3 in the series to learn more.